So this section 4.4 is all about building quadratic models from verbal descriptions and from data. So this is a lot of word problems. So keep that in mind. So friendly reminder, when you have a parabola, if you have an a less than 0, so an a that's negative, that parabola is inverted and upside down, right? So its vertex is its maximum. If I have a parabola whose leading term's coefficient is greater than 0, so a positive number, then our vertex is our minimum. So keep that in mind for this section. So let's enclose a rectangular field. David has 400 yards of fencing and wishes to enclose a rectangular area. So I want to express my area of my rectangle as a function of W, which is the width of the rectangle. So first let's draw our rectangle. The equation for the perimeter of a rectangle is 2W plus 2L equals our perimeter, which we know to be 400, right? And the area of a rectangle is typically width times length. Not typically, it always is width times length. I guess we changed colors. So if I only have 400 feet of fencing, I know that 2W plus 2L equals 400. And what I'm going to try and do is I want to express my area as a function of W. So I'm going to go ahead and solve this for L so we can substitute into our equation for area. So if I have 2W plus 2L equals 400, and I subtract 2W from both sides, I get 2L equals 400 minus 2W. We divide both sides by 2. I get L equals 200 minus W. I can then define area in terms of our width W as 200 minus W, our length, times our width. And this is going to simplify down to 200 W minus W squared, but we're going to go ahead and rearrange our terms so that we have our highest degree term first. So there I have the area of a rectangle expressed via width. And I want to know for what value of W is our area the largest. So W is like our x, right? So here's our parabola. I know it opens upside down, right? So what I'm trying to find is my x, which would be the h coordinate of our vertex, right? Remember that our vertex, h equals negative b over 2a, and k, our y coordinate, is f of h. All right? So h would give us the width, and then a of w gives us the area. So I first need to find my h. So if I have h equals negative 200 over 2 times negative 1, that gives me negative 200 over negative 2, so 100. Okay? So when w is 100, I'm going to have the largest area. And to find that maximum area, I need to substitute into AW equals negative W squared plus 200W. I have to substitute in 100. So A of 100 equals negative 100 squared plus 200 times 100. That gives me negative 10,000 plus 20,000, which is just 10,000. So here is our first example using a parabola to find, and what we know about quadratic functions to find the area, the maximum area of a rectangle. Now, what if I have a farmer who has 2,000 meters of fencing and he wants to enclose a rectangular plot that borders a highway? So I've got my highway here, okay? Here's my highway. Got little cars on my highway. Not a very good artist, but here's my rectangle. So let's let this side be x. I've got 2,000 meters, so the whole perimeter of this would be 2,000. So if I have 2,000 minus 2 times x, that would be the length of this long side. So my area would be x times 2,000 minus 2x. So my a of x is negative 2x squared plus 2,000x. Now, I want to know what the largest area is that can be enclosed. So the first thing I need to find is my maximum, right? This is a parabola that opens upside down. I need to find my h value of my vertex. So h equals negative b over 2a. That equals negative 2,000 over negative 2, positive 2 times negative 2. That gives me negative 2,000 divided by 4, negative 4. So I get a positive 500. In order to determine my maximum area, I then plug this into my function. So a of 500 is negative 2 times 500 squared plus 2,000 times 500. So a of 500 equals negative 500,000 plus 1 million. So many zeros. And that's going to give me an area, a maximum area of 500,000 meters squared. Next, we have a suspension bridge. This suspension bridge, it has its weight uniformly distributed along the length. It has identical towers. Okay, let's draw a picture. These identical towers are 75 meters tall, and they're 400 meters apart. The cables are in a parabolic shape. We love parabolas. And they touch the center, touch the road at the center of the bridge. I want to find the height of the cable at a point 100 meters from the center. Well, we've got our 400 meter length. Let's let this middle part be our origin. So then here we've got 200 meters, and here we have like negative 200 meters, right? So now we have a nice little XY plane. So the first thing I'm going to do is I know that because the origin 0, 0 is my minimum, that's my vertex, my equation is going to be of the form y equals ax squared, because we aren't adding anything to shift my parabola vertically or horizontally. Well, I have one point. I know one point on this graph. I know when x is 200, y is 75. So I can use this information to solve for a. 75 equals a times 40,000. If I then take 75 divided by 40,000, I get 0.001875 is my a. So I now have the equation y equals 0.001875 x squared. And I used a decimal this time because I didn't want to have to keep track of a fraction. But typically I'd leave it in fraction form. So now I can find my height, y, right here, this orange spot, if I substitute in when x is 100 to my equation. So if I have y equals 0.001875 times 100 squared, that's going to give me 18.75 meters. So the height of my cable, 100 meters from the center, is going to be 18.75 meters. Next, the price P in dollars of the quantity of X M&Ms of the quantity X sold of M&Ms satisfies the following demand equation. Let's find a model that expresses revenue as a function of P. So remember that revenue equals the quantity sold X plus P. So R of P would be, if I substitute in this for X, I've got P times negative 20P plus 500. So our revenue would be negative 20P squared plus 500P. Next, we want to find our domain. Okay, so we know that we can't sell any less than 0. So 0 is less than the amount sold. Well, 0 is less than our X as it's defined, which is negative 20P plus 500. And I can solve this. I'm going to subtract 500 from both sides. I get negative 500 is less than or equal to negative 20P. I divide both sides by negative 20, remembering to flip my sign because when you divide by a negative, you have to flip your inequality sign. So I get that I know it has to be greater than 0, but it has to be less than 25. So here we can charge between 0 and $25. Next, I want to know what price P maximizes my revenue. Note, this parabola will be shaped upside down. So if I want to find my price P that maximizes my revenue, I'm going to have to solve for H. H is negative B, just one B, over 2A. So I have negative 500 over 2 times negative 20, and that's going to give me 500 divided by 400. Let's call it, not 440. So that gives me 12.5. Okay, this is the P that maximizes the revenue. So if I want to know what my maximum revenue was, I would plug in our maximum P. So I'm going to go ahead and do that. And I find that my maximum revenue is $3,125. Now, if I want to know how many units are sold at this price, I would use my original equation for the number sold, which is X equals negative 20P plus 500. So X equals my revenue which is our price, right? Negative 20 times our price plus 500, and that's going to give me X is negative 250 plus 500, so 250 units are sold at that price. I can graph this in Desmos. So let's go to Desmos and go ahead and graph. So I can see what this looks like. If I have R of, let's change our variable to, let's let R of P, hopefully this works, R of P equals negative 20P squared plus 500P. And I can zoom out and see my graph, right? All the way up here. What did we say our maximum value was? 3,125. There we go, 325. So we can go ahead and graph this function. Next, I want to know what price the company should charge to earn at least $30,000 in revenue. So, in order to solve this, I'm going to take my revenue equation, R of P equals negative 20P squared plus 500P. I'm going to set that equal to 3,000. And I can go ahead and solve. I need to go ahead and move this 3,000 over so I can factor and use the zero factor property. So I have 0 equals negative 20P squared plus 500P minus 3,000. I can pull out the greatest common factor, which is negative 20. So I have P squared minus 25P plus 150. And I factor this to be negative 20, P minus 10, P p minus 15. And I set each of these equal to 0, and I find that p has to be between $10 and $15. Last but not least, I didn't do this one in class, but there was one on the worksheet that a couple people asked me questions about, so I thought I'd do an example of the motion of a projectile. Now, I heard in class people mentioning, oh my gosh, this reminds me of my traumatic physics class, and it should, because we're talking about velocity and things like that, but you don't need to know anything from physics to solve this problem. So let's take a look. A projectile fired from a cliff above water. So here's my cliff, and then here's my water. At an inclination of 45 degrees to the horizontal with a muzzle velocity of 50 feet per second. The height of our projectile above the water is given by this formula. Okay, things I didn't need to know. This 45-degree angle doesn't matter, right? We're wondering what the height of the projectile is. That's all we care about. We don't care about force, velocity, right? Here's my parabola. And we want to find at what horizontal distance, so here, i.e. our vertex, from the face of the cliff is the height of a projectile at a maximum. We're still just solving for h. Well, this gives me -1 over -32 divided by 50 squared, which is 2,500. Let's just write it like that. So I'm going to get a positive 2,500 and over 2 times 32, so over 64. And that's going to give me 625 sixteenths, which is 39.0625. Okay, so that is the distance from our cliff, 39.0625 feet, where my projectile reaches its peak. Now, if I want to find the maximum height of my projectile, I have to find my k. So I'm going to take h of 39.0625, and this gives me -32 times 39.0625 squared, right, over 50 squared, plus 39.025, because I'm plugging in my x, plus 200. So we are going to go ahead and square this. We multiply it by -32. We divide it by 50 squared. We're going to get -19.53125 plus 39.0625 plus our 200. So we get a maximum height of 219.53125 feet. Now on the homework, it will tell you specifically how many decimal points it wants you to round it to. I kept track of all of mine, again, feeling kind of nerdy.